Hello, this is Frank with Frank's Beautiful Rocks and Minerals. To see my collection of beautiful minerals and crystals, go to my website, Frank's Beautiful Rocks and Minerals. I have a website right now that's been under construction. It's a blogspot website, Frank's Beautiful Rocks and Minerals. I advertise that I sell minerals and crystals and do pollution testing for drinking water and soil and air. I'm going to switch over and make a new website on Wix, advertising my services of testing people's drinking water for toxic chemicals, poisons, fertilizers, runoff, sewage, bacteria, soil, and also selling beautiful minerals and crystals. I'm a prospector. I travel the world. I travel the United States. I collect the minerals. I clean the minerals. And I put the minerals in handmade boxes of wood and red felt that I carve and cut for free and display for you to display the minerals and crystals. For your enjoyment. Anyway, there's a topic called structural geology. On the internet, if you type in structural geology, a woman has cartoons and goes over structural geology very well. She is the best, and I recommend that you type in structural geology and watch her notes and listen to her speak and learn as much as possible. But she doesn't show examples. I'm going to show examples of minerals fracturing, cracking, and failing in today's lab. So let's get to it. It's my new stereoscope. That I just got for mineralogical analysis. Has two settings, low power and high power. My old scope is a Wolf. That's American Optical. This is Wolf. American Optical has a light that shines through your specimen and a light that shines down on it, and a switch for low and high power. And my Wolf has an interchangeable disc of black and white background, and has not just low and high power, but 3 levels of power, low, medium, and high. But you have to take a lens off. You have to take a lens off first. In fact, the lens is off right now, and I wonder where the lens is. And I like my stereoscope. Stereoscopes are really good for identifying minerals by means of their crystal structure, to identify them by their crystals, whether they're hexagonal, trigonal, tetragonal, rhombohedral, octahedral. Determinations is important and necessary to use a stereoscope to really identify a mineral in terms of its crystal structure, because its crystal structure is a major determination factor and must be observed. For larger crystals, gonionomers, like I've bought here, and I have here, whoops, that are very sensitive instruments and shouldn't drop, I have for crystal measurements. So you can measure the six-sided prismatic crystal of an amethyst, for example, hexagonal, or fluorite, octahedral, with 4 sides. Stress. Well, I feel I'm not really going to focus on defining stress, strain, and the definitions in geology for you in this video. We're playing around in the lab. It's 3 in the morning. We're playing around in the lab. That's what a lab's for, to play around in. But anyway, pressure applied to a rock. Rock can be subject to several different kinds of stress. Lithostatic stress. Remember Newton's equation. Force equals mass times area. Differential stress is a compression. Tension is a shearing. Because this becomes important in terms of how stress causes strain on a object, and body forces and surface forces. A body force may suddenly be jarred and broken by the deacceleration of hitting the ground surface as you see in that diagram. There are different types of stress described, and stress in an object can be described in vector components. You can draw yourself a stress ellipsoid, for example, to show you the stress in a sample of or a specimen of a mineral. Here's an example of a tensiometer in a Moore's circle. Moore's circle can represent strain and stress in an object, a solid. Over here we see the failure point at which the object breaks, which we'll be playing with in the lab. Theoretical stress trajectory of a block being pushed over by a resistance force. So, look up stress, strain, fracture, and structural geology, and you'll find that woman who I found and took careful notes of, and these are my notes of, her subject of, these are Griffith cracks, modes and shear, and she'll discuss and really go in depth about the different types of stress and strain and cracks and definitions. But let's have fun in the lab. Alright, what have I done? Some of the rocks that I collect, that I sell, are specimens that contain, or granitic specimens, or caustic granitic specimens, maybe aphanitic or phonetic, doesn't matter. But they contain veins. Veins were another mineral leaked in, settled in, and solidified, forming a vein. Here we have a vein of hornblende and granite. Hornblende. Here we have a specimen of a vein of calcite in granite. Here's calcite in chert. Here's a vein of calcite in granite. The calcite is soluble in acid rain, dissolves, and it seeps into the cracks and fissures of the rocks of granite and forms calcite veins in the process. This is ruby granite with calcite veins. These are the specimens we'll be playing with. My lab's large. I got a lot of fun. I have to admit, it's nice being a sole proprietor, a business owner, being your own boss. You can, not that I do, but you can make videos not wearing your shoes in the lab. You cannot wear your safety glasses and lab coat while working with chemicals in the lab. You can break all the rules you want in the lab. You're your own boss when you own your own company. Actually, Frank's Beautiful Rocks and Minerals follows all guidelines of GLP and OSHA and standard methods and procedures according to standard methods of water and wastewater analysis. But it is nice being your own boss. You can make your videos anytime you want. Tonight it's 3 in the morning. I have a rhombohedral piece of calcite. I have some table salt, halite. I already was trying to